I hope all of you are doing good, and I am back with the third video of the video series on Gravitation Class 9 Science. Now, as you all know that when we learn physics, it's not just about learning and understanding the concepts. It is also important that we understand how we use those concepts or how we apply those concepts in real life problems. Now that is what we are going to do exactly in this video. So in this video, we are going to look at some questions related to universal law of gravitation as well as acceleration due to gravity. So this is going to be a super important video as well as a super interesting one as well. Let's get started.
So now let us try to solve some problems based on the universal law of gravitation and also acceleration due to gravity. So let us look at the first problem. What is the magnitude of gravitational force between the Earth and a 1 kg object on its surface? Okay, so we will make use of the universal law of gravitation. So here, what are the two objects between which we are trying to calculate the gravitational force? One object is the Earth and the other object is this 1 kg object, right? So let us suppose mass of M1 would be the mass of the Earth, which is 6 into 10 to the power 24 kg. What will be M2? M2 is the 1 kg object, and it says that the 1 kg object is lying on the surface of the Earth. So you have the object here, right? So what is the distance between the object and the Earth? We always measure the distance from the center of the Earth. So the distance would be nothing but the radius of the Earth. And what is the radius of the Earth? It is given as 6.4 into 10 to the power 6 meters. Right? So now applying universal law of gravitation, we know that G is equal to F is equal to G m1 m2 divided by r square. So G, we know the value of G as 6.67 into 10 to the power minus 11 into m1 is 6 into 10 to the power 24, m2 is 1 divided by r square, that is 6.4 into 10 to the power 6 whole square. So this value comes out to be 9.7 Newton approximate. So this would be the magnitude of the gravitational force between the Earth and the object. So let us look at the second problem. It says gravitational force on surface of moon is only 1/6 as strong as the gravitational force on Earth. Okay, so what is the weight in newtons of a 10 kg object on moon and on Earth? So that means it says that the weight of an object, if I'm talking about the weight of an object, what will be the weight on moon? Will the weight on the moon and Earth different? Yes. Why so? Because when I'm talking about weight, I'm actually talking about the force experienced by the object because of the gravitation, right? And as I mentioned before, the acceleration due to gravity will have different values on Earth and moon. So how do we define weight? Weight is nothing but mass of the object multiplied by the acceleration due to gravity, right? Now, the problem itself says that the acceleration due to gravity on moon is equal to 1/6 the acceleration due to gravity on Earth, right? So therefore, the weight of the object on moon will be equal to, right? So this will be equal to, and what is the mass of the object? Mass of the object is given as 10 kgs. So this will be 10 into, what is GE? That is acceleration due to gravity on Earth is equal to 9.8 meter per second square. We determined that value in one of our previous slides, right? So this will be 10 into 9.8 divided by 6. So this comes out to be 16.34 newtons. So this would be the weight of the object on moon. So what would be the weight of the object on Earth? It will be mass into acceleration due to gravity on Earth. So that will be 10 into 9.8, that is equal to 98 newtons. So you can see here practically that how the weight of an object varies from Earth to moon. So let us look at the third problem. It says that a ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate the maximum height to which it rises and the total time it takes to return to the surface of the Earth. Okay, so let us first look at the first part. Now what are the values which are given here? It was thrown upward with a velocity of 49 meter per second. So that means the initial velocity is 49 meter per second. Right? So we have to, what happens actually, the boy throws the ball, it reaches a maximum height. So first the ball goes up, it reaches a maximum height, let us say that it reaches this point A, and then it starts falling down again and come back to the earth. That is what is happening actually, right? Now when it reaches height at this point, what is its velocity? Its velocity is 0, right? So the final velocity is equal to 0 at point A. That means at maximum height, right? So we have to calculate the height till which it rises. That means this is the initial velocity. So this is my starting point and this is my ending point for now. Because right now I just want to calculate this maximum height. So we have to calculate the total displacement. And what is the acceleration due to gravity? It is 9.8 meter per second square. Now the ball is thrown up, so it will be with a negative sign. Now, which equation should I make use of here? If we know u, v and g, but we have to calculate s, so we will make use of the third equation, that is v square is equal to u square plus 2gs. So this will be minus 2gs because this g has a minus sign, right? So this will be 0 is equal to 49 square minus 2 into g into s. So from this we can calculate s as 49 square divided by 2 into 9.8, 122.5 meters. So this would be the maximum height to which it rises, right? So now in the second part, it asks us to calculate the total time it takes to return to the surface of the earth. That means first it rises from here, then it comes back to here. So the total time, so upward journey's time plus downward journey's time. So this is ascent and this is descent. So we have to calculate here the total time. So the total time will be time of ascent plus time of descent. That means the time taken to reach the maximum height and then the time taken to fall back to the earth from the maximum height, right? So let us first try to calculate the time of ascent, right? So only the upward motion, let us apply the first equation of motion, that is v is equal to u plus at. So this we can write as v is equal to u minus gt. Now v is 0, u is 49 minus 9.8 into t. So this t is nothing but time of ascent. So this is ta. So from this we can calculate ta as 49 divided by 9.8, which is equal to 5 seconds. Right? So 5 seconds is the time which it will take to reach the maximum height. But then again it has to fall back from the same height to the ground. So while falling back again, the time of descent will be 5 seconds because time of ascent is always equal to the time of descent. So therefore the total time it will take to return to the surface of the earth is time of ascent plus time of descent, which is equal to 5 plus 5, that is equal to 10 seconds. Now if you are not convinced with the fact that time of ascent will be equal to time of descent, you can also calculate time of descent separately and you will find that time of descent also comes out to be 5 seconds. How can you calculate the time of descent? You can make use of the second equation of motion. So I will do it here. To calculate time of descent, we can make use of this equation. S is equal to ut plus half gt square. So here g will be plus because now the object is falling down, right? So the g will be positive. So in this case, now in this motion, now here the initial velocity will be velocity at this point, right? So the initial velocity will be equal to 0 in this case because now the motion is starting from this point. So the previous final velocity will become its initial velocity. So now initial velocity will be 0 plus half into g is 9.8 into this t time is nothing but the time of descent. So this is equal to the s and s is 122.5. We have calculated this s, that is the total distance. So from this if you calculate, you get time of descent is equal to 5 seconds. So whether you calculate it this way or you directly write it, both are all the same because during a free fall, when an object is thrown up and it falls down and it reaches the surface of the ground, your time of ascent is always equal to the time of descent. Right? So now you're able to understand how we make use of the equations of motion. Anyways, we have solved these kind of problems in our previous lessons also. The only difference here is that your acceleration got replaced with the acceleration due to gravity. Right? Okay. Now let us look at the fourth problem. It says a stone is released from top of a tower of height 19.6 meters. Calculate its final velocity. So the stone is released from the top of this tower, right? That means initially the velocity was 0 because initially the stone was at rest at the top of the tower. What is the height of the tower? That is, height of the tower is nothing but the total distance that will be traveled by the stone. So that is 19.6 meters. We have to calculate the final velocity, and acceleration due to gravity is 9.8 meter per second square. So having these values, we will make use of the third equation, which is v square is equal to u square plus 2gs. We have taken plus because the body is falling downwards. So from this we can say this would be 0 plus 2 into g into s. So this will be equal to 384.16. Or we can say v is equal to root over 384.16, that is equal to 19.6 meter per second. So this would be the final velocity of the stone. Let us look at problem 5. It says a ball is thrown vertically upward with an initial velocity of 40 meters per second. Okay, so the initial velocity is given as 40 meter per second. Taking g is equal to 10 meter per second square. Now the value of acceleration due to gravity is actually 9.8 meter per second square, but many a times, just to keep calculations simple, it is rounded off to 10. So here the problem says that g, you should take it as 10 meter per second square. We have to calculate the maximum height reached by the ball. It is again a similar kind of problem. So maximum height means the total distance we have to calculate. And at maximum height, the final velocity would be 0, right? So at maximum height, your final velocity becomes 0. So we can make use of the third equation of motion, that is v square is equal to u square minus 2gs. Here minus because the object is going upwards. So 0 is equal to 40 square minus 2 into 10 into s. So from this we can say s is equal to 40 into 40 divided by 20. So that is equal to 80 meters. So 80 meter is the maximum height that would be reached by the ball. We have to also calculate the net displacement and the total distance covered by the ball. So 80 meters is just one way. This is 80 meters, the maximum height reached by it. So what would be the total distance? Total distance would be this distance plus this distance, because first it goes up and then it will again fall down, right? So the total distance would be s plus s, that is equal to 80 plus 80, which is equal to 160 meters. What would be the total displacement? Now when I talk of displacement, it is nothing but the distance between the initial point and the final point. So initial point was this, final point is again this because it falls back to the ground. So therefore the total displacement will be equal to 0. Calculate the force of gravitation between the earth and the sun, given that the mass of the earth is 6 into 10 to the power 24 kgs and that of the sun is 2 into 10 to the power 30 kgs. The average distance between the two is 1.5 into 10 to the power 11 meters. So here the two objects which we have are the earth and the sun. So we will make use of the universal law of gravitation, which says G m1 m2 by r square is equal to F. So here m1 is mass of the earth, which is 6 into 10 to the power 24 kgs. m2 is mass of the sun, which is 2 into 10 to the power 30 kgs. R is the distance between the earth and the sun, which is 1.5 into 10 to the power 11 kgs. And the value of G we already know as 6.67 into 10 to the power minus 11 Newton meter square per kg square. Right? So now we can calculate F as 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 2 into 10 to the power 30 divided by 1.5 into 10 to the power 11 whole square. So this value comes out to be 3.56 into 10 to the power 22 newtons. So this would be the force of gravitation between the earth and the sun. Let us look at problem 7. Here the problem says a stone is allowed to fall from the top of a tower 100 meters high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meters per second. These are the two stones. So for the first stone, it says that the stone is thrown from the top of this tower. So that means that this stone is going down. For the stone S2, the stone is thrown or projected vertically upwards in this way. Now we have to calculate the point where these two stones will meet. So let us suppose that the two stones, this is coming down, this is coming up. Let us suppose that the two stones meet at point P. And let us suppose that the distance of this point P is x from stone S1, that is from the up of the tower. So what would be the distance of the stone of this point P from the bottom of the tower? The total height of the tower is given as 100 meters. So this distance will be equal to 100 minus x. Right? So we have to actually calculate this value of x, and we have to also calculate the time after which they will meet at this point. Right? So now let us first consider stone S1. So for S1, what is the distance traveled? The distance traveled till point P is x. Right? What was the initial velocity? So it was thrown from the top of the tower. That means initially it was at rest at the top of the tower. So initial velocity is 0. How much is the time taken? Let us suppose that the time taken to reach this point P is t. So it takes t time to reach this point P. So now we can write this second equation of motion as S is equal to ut plus half gt square. So here g is positive because the stone is falling down. So in this we can put this value. So this becomes x is equal to 0 plus half gt square, or we can say what is the value of g? Let us take g as 10 meter per second square. So this will be 10 into t square. So this is 2 5s 10. So we can write x is equal to 5t square. So this is my first equation for stone S1. Now let us do the same thing for the stone S2. Now for S2, what is S? S is the distance travelled, that is 100 minus x. Right? What is the initial velocity for stone 2? Now in the problem it is given that it is projected with a velocity of 25 meter per second. So that means initial velocity is 25 meter per second. Right? And let us suppose the time taken is t, because the time taken will be same, right? Because they are meeting at this point. That means both would have travelled this much distance till point P in the same time. So here again, let us write down the equation, which is S is equal to ut plus half gt square. So this can be written as 100 minus x is equal to 25 into t plus half into 10 into t square. So this is 2 5s are 10. So we can write it as x is equal to 100 minus 25t plus 5t square. So this is my second equation. Now from equation 1 and 2 we see both the equations have their left hand side as x. So their right hand sides should also be equal. So from equation 1 and 2 we can say that 5t square should be equal to 100 minus 25t plus 5t square. Right? So this 5t square and 5t square will get cancelled. So from this we get t is equal to 100 by 25, that is equal to 4 seconds. That means, so we got one answer. It was asking calculate when. So we already found the answer for when. So the two stones will meet after 4 seconds. Right? So one problem is solved. And where? That means we have to calculate x. Now once we found t, from equation 1, we can calculate x. So from equation 1, x is equal to 5t square, that is 5 into 4 into 4, that is equal to 80 meters. So this x is 80 meters. So what would be 100 minus x? So 100 minus x will be equal to 100 minus 80, that is equal to 20 meters. So that means the two stones will meet at a distance of 20 meters from the ground after 4 seconds. Right? So this, because this will be 20 meters, so they are meeting at a distance of 20 meters from the ground after 4 seconds. So here you saw this problem was little different one, but here also we used the same equation of motion and we just equated them. So the thing is that if you are good to go with the equations of motion, if you have understood how to apply the equations of motions correctly, then you can solve even little tricky problems also. Now let us look at the last problem of this section. It says a ball is thrown up vertically, returns to the thrower after 6 seconds. Okay. Find the velocity with which it was thrown up, the maximum height it reaches, and its position after 4 seconds. Okay. So in this case, the time which is given as 6 seconds. What is that time? That is the total time that the ball takes to go up and to come down. That means time of ascent plus time of descent is given as 6 seconds. So this implies the time of ascent and time of descent each is equal to 3 seconds, right? Because time of ascent is equal to time of descent. So now in the first problem, we have to calculate the velocity with which it was thrown up. So the stone was thrown up from here. So we have to calculate the initial velocity, right? Now the stone will reach a maximum height. So at maximum height, the final velocity will be equal to 0. Correct? So we can make use of the first equation of motion, that is v is equal to u minus gta, minus because the stone is going up, so the acceleration would be minus ta, that means the time of ascent, the time taken to go up. So using this we can say u is equal to v plus g into ta. So what is v? That is 0 plus g, let us take g as 10 meter per second square, into ta, that is 3 seconds. So this will be equal to 30 meter per second. Now I am considering g as 10 meter per second square just to simplify my calculations, but otherwise you should consider the accurate value, that is 9.8 meter per second square, except for problems which explicitly mention that please take g as 10 meter per second square. Now the next part, the maximum height it reaches. So that means we have to again calculate the total displacement or the total distance that it will cover. So we will make use of the second equation, that is s is equal to uta minus half gta square. So ut minus half gt square. So this will be equal to, what is u? U we have just now calculated as 30 meter per second. So this will be 30 into 3 minus half into 10 into 3 square. So this comes out to be 90 minus 45, which is equal to 45 meters. So this 45 meter is the maximum height the stone will reach. Now in the third part, we have to calculate its position after 4 seconds. Now what is the position of the stone after 3 seconds? 3 seconds it reaches the maximum height. So 4 seconds means this point it will reach, after that it will start falling down. So it will be somewhere at this point. So we have to calculate this position, that means the distance of this point from the ground. So this is the distance covered in 3 seconds and the distance which it covers in another 1 second. Correct? So in the third part, we see that in 3 seconds it reaches the maximum height. So in another 1 second, what happens? It starts falling down. So we have to see in another 1 second how much distance it travels. So let us suppose that in another 1 second it travels a distance of s dash. So what will be that s dash? We can calculate it. S dash is equal to ut plus half gt square. Now in this case, initial velocity would be the velocity at the top of the tower, which was 0, plus half into g is 10 meter per second square. T is 1 second because we are calculating it for 1 second. So this will be equal to 5 meters. So that means in 1 second it traveled 5 meters. So that means in 4 seconds, what was its position? So if you look at the height of the tower, what is the height of the tower? It is 45 meters, right? Just now we calculated the maximum height. So this is the height of the tower. In 1 second it traveled 5 meters. So that means it is at this point P currently. So we have to find out the position of this point P. So position of point P will be 45 minus 5. That is equal to 40 meters from the ground. So this would be the position of the point or the position of the stone after 40 seconds, after 4 seconds, right? So I hope with these many problems, your concepts or the theoretical concepts which we studied in the universal law of gravitation and acceleration due to gravity have become better. So now we will talk about the remaining topics of this lesson.
I hope you found the video useful. Please let us know your feedback in the comment section because your feedback is important to us. I will meet you guys very soon with a new video with a new topic. Till then, take care. Bye-bye.